All right, let's dive right into one of the most highly debated absolute heavyweight matchups in the entire crypto world, Solana versus Ethereum. Which one actually wins, and why exactly is Solana so much faster? Today, we're going to unpack the fundamental engineering choices driving these two massive networks, because you see, these two giants represent completely different philosophies on how to build decentralized systems, and in this explainer, we're going to break down exactly what makes them tick.
To start, I want you to picture this. Imagine you've built a hugely popular decentralized exchange, right? You're processing about 100,000 daily transactions. Well, based on recent data, if you're running that on the Ethereum mainnet, your users are collectively paying up to $1.5 million a month in transaction fees just to use your platform. That is a massive amount of friction for any business trying to scale. But get this, here is the shocking contrast. Processing that exact same volume, 100,000 daily transactions, on Solana costs your users a mere $750. That's a staggering 20,000 times cost difference between the two base layers. And honestly, that single metric alone completely changes what is economically viable to build. So here's our roadmap for today's explainer. First, the heavyweight match. Second, under the hood, virtual machines. Third, why Solana is faster. Fourth, the cost of speed. Fifth, real-world use cases. And finally, who wins the war? Okay, part one, the blockchain heavyweight match. Let's lay out the current landscape between these two dominating ecosystems. When we put the base layer metrics side by side, the fundamental divide becomes crystal clear. Ethereum's base layer deliberately limits its throughput to about 15 to 30 transactions per second, with block time sitting around 12 seconds. Solana, on the flip side, is operating at thousands of transactions per second, routinely hitting 1,000 to 4,000 TPS in the real world, with near-instant block times of just 400 milliseconds and fees that are literally fractions of a cent. But here's the absolutely crucial thing you need to take away from this. This isn't just about raw speed. It's a massive, highly intentional engineering divergence in how we build global decentralized state machines. The speed difference isn't some happy accident. It's the direct, calculated result of how these networks are architected right from the ground up. Which brings us nicely to section 2, under the hood, virtual machines. Because you simply cannot understand the performance of these networks without understanding the engines powering them. Think of it like this. A virtual machine is essentially the blockchain's engine. It's the operating system, the environment where smart contracts live and actually execute. And Ethereum and Solana, well, they use two completely different engine designs, the Ethereum Virtual Machine, or EVM, and the Solana Virtual Machine, the SVM.
Let's move to section 3, why Solana is faster. This is the real core of our focus today. How do these different engines actually dictate performance?
We can see the massive differences in transaction throughput on paper, sure, but how exactly does Solana physically achieve this incredible speed compared to Ethereum? Well, the answer lies in how they handle state and execution. You can think of the Ethereum EVM kind of like a single-lane road. Smart contracts contain both their code and their data bundled together. That's a coupled state, which means transactions have to be processed one at a time sequentially to avoid any conflicts. Solana's SVM is entirely different. It uses a decoupled state, where the logic is separate from the data accounts. This allows Solana to act like a multi-lane highway. It uses an engine called C-level to process thousands of non-overlapping transactions simultaneously across multiple CPU cores. And it gets better. Solana pairs this multi-lane highway with something called proof of history. Now, while Ethereum validators have to spend time communicating back and forth to agree on the order of transactions, proof of history acts as a decentralized cryptographic clock. It actually timestamps transactions before they're even grouped into blocks. This lets nodes agree on time instantly, completely skipping the slow communication process that traditional blockchains get bogged down by. But hey, let's look at section 4, the cost of speed. Because in computer science, you know there are no free lunches. We have to impartially examine the trade-offs required to reach that mind-bending speed. To handle that massive parallel highway and process thousands of transactions per second, Solana requires its operators to use highly expensive enterprise-grade server hardware. We're talking 256 to 512 gigabytes of RAM. Now, this can concentrate validator power among those who can actually afford the setup. Ethereum, conversely, prioritizes making it easy for pretty much anyone to run a node from home on consumer-grade hardware, prioritizing maximum decentralization over raw base layer speed.
So instead of demanding extreme hardware to scale up the base layer, Ethereum's philosophy relies on a modular approach using Layer 2 rollups. Networks like Arbitrum, Optimism, and Base act as secondary layers that process transactions cheaply and quickly off-chain. They then bundle thousands of these transactions together and post the cryptographic proof back down to the highly secure, decentralized Ethereum mainnet. It's just a completely different roadmap for scaling.
Moving on to Section 5, real-world use cases. Because these two engines are optimized for entirely different things, they naturally attract completely different types of applications. If you're a major financial institution moving hundreds of millions of dollars, you're going to choose Ethereum. Its slower but incredibly secure, battle-tested single-lane road is preferred for institutional DeFi, high-value secure settlements, and tokenized real-world assets. The focus here is all about deep liquidity and ultimate peace of mind. Conversely, if you're building a highly interactive video game, a fully on-chain limit order book for high-frequency trading, or a social app that requires sub-cent microtransactions, well, Ethereum's architecture simply isn't going to work for you. For those applications, Solana's parallel processing, raw throughput, and practically non-existent fees are absolutely essential to create a seamless experience for the consumer.
And finally, Section 6, who wins the war? Let's definitively answer which blockchain actually claims victory in this heavyweight matchup. The objective truth, straight from the data, is that neither chain objectively wins. Why? Because they aren't even playing the exact same game. Ethereum optimizes for credible neutrality, ultimate security, and decentralized scaling via Layer 2s. Solana optimizes for maximum base layer throughput, minimal latency, and a unified state. Honestly, the future points heavily toward a multi-VM ecosystem, where both of these giants thrive in their own specific specialized lanes. But as both chains continue to drastically upgrade their tech, with Ethereum pushing its roll-up scaling and Solana testing the million TPS Firedancer client, it leaves us with one massive, provocative question to ponder. Will the next billion users prioritize the localized, layered security of Ethereum's ecosystem, or will they demand the frictionless, unified speed of Solana? It's going to be a fascinating space to watch.